This section will instruct the builder to install the control systems of the EXEC 162F helicopter: the cyclic control, the collective control, and the directional control. Locate the following components: reference construction prints E14-2000 cyclic control. This shows the completed installation of the cyclic controls for the pilot and passenger. Using template E14-2, cut out and drill the holes in the push-pull control T. Note, verify the 1 1/4 inch measurement before drilling holes. Use template E14-3 to cut out the cyclic handle covers. The cyclic handle can be shortened for pilot comfort and chrome-plated or painted. Fit the cyclic stick, the cyclic clevis, and the cyclic boot and handle. Do not glue or rivet the handle to the stick at this time, but wait until all wiring is completed, then glue the back cover to the cyclic handle using a 2-part epoxy. The handle can then be riveted to the stick. Note, the push button for the starter will be located on the pilot cyclic handle when the wiring harness is installed. Take care to ensure that the wires do not fray when they exit the cyclic stick. This could cause a short, resulting in starter engagement at full RPM during operation. Make a slot 1/4 inch wide by 1/2 inch long in the pilot's cyclic stick just above the clevis to route the starter button wiring. Make the same slot in the passenger stick in case you plan to have a push-to-talk communication switch on the passenger's handle. With cyclic stick installed in the clevis, make sure the bend for the handle is 90 degrees to the clevis opening as shown. Notice the clevis has an extended fork tip for the dual lateral shaft. This should be installed facing the front of the ship as shown. Drill a 3/16 bolt hole that holds the stick in the clevis. This shows the bolt installed in the clevis. Before the cyclic control shaft can be cut to length, the front landing gear and seat must be in position and bolted in place. Failure to do this will give the wrong length to cut the control tube. To cut the cyclic shaft to the correct length, install the aluminum and nylon bushings on both cyclic control brackets on the airframe as shown. Check the length of the cyclic shaft by holding it next to the pivot bushings. Cut it to length for a snug fit. Referring to the construction print, it shows that the cyclic clevis bushings are cut to 1 7/16 of an inch long. Make sure that there's at least 7/32 of bushing remaining past the tube and they are equal in length. When installed, the nylon clevis bushings will be snug against the shaft bushing, and the large fender washer must be close but not touching the clevis as shown. Drill the 2 bushings using a letter D drill. This is a close tolerance fit. Install the cross tube with nylon and aluminum bushings with the bolts. Note, on final assembly, the mating parts should be coated with grease, the bolts will be safety wired, and the aluminum bushings will be riveted to the airframe brackets. Install one nylon bushing in the clevis. Remember to allow just enough bushing to stick out so that the large fender washer does not touch the clevis. Position the clevis on the cyclic shaft and install the 1/4 inch bolt, fender washers, and the other nylon bushings that hold the clevis to the shaft. Do not over-tighten. The clevis must not bind through its range of travel. On final assembly, the mating part should be coated with grease. Install the 1/4 inch bolts and the jam nuts that are used to set the lateral control stops. On final rigging, you will set the range of travel to 52 degrees. Install the fore-aft control cable in the airframe bracket as shown. Install the control T that you fabricated earlier with the supplied hardware. Now check the alignment of the rod end with the fore-aft cable bracket as shown. The construction print shows that this hole center should be between 13/16 to 15/16 of an inch from the control shaft. Before drilling, verify that the ratio is correct between the cyclic and the swash plate. The cyclic's range of movement fore and aft is 52 degrees, and the swash plate range of movement is 10 degrees. If you need to reduce the ratio, move this hole toward the pivot. If you need to increase the ratio, move it away from the pivot. Drill the hole after verification. More information about finding the correct ratio can be found in Section 25 Rigging, Swash Plate. Install the lateral cyclic control cables in the shaft bracket as shown with their lock nuts. Install the T and the male rod end. If you are installing the dual control stick, assemble the dual lateral shaft as shown. Install the 4 aft stop bolts and nuts as shown. On final rigging, you will set the range of travel for the 4 aft to 52 degrees using a protractor level. Route the lateral cyclic cable as shown to prevent kinking and interference with the gas tank. Install the cushion loop clamps on the 1-inch airframe support tube on the passenger side as shown. Wrap one clamp around the cables and the other around the tube, joining them together with a 3/16-inch bolt. Note the location on the airframe. Locate the following components: Reference Construction Prints E15-2000 Collective Control. The seat back will be installed so that the collective cross tube can be fitted. Cut holes in the seat back where the pilot and passenger collective stick will come through as shown. The opening should be as small as possible and can be enlarged after the collective is installed. Use a file to help align the fit. Install the aluminum and nylon bushings in the collective mounting brackets. Hold the collective in position and mark the ends to be trimmed on the cross tube. Trim from each end to keep the pilot and passenger stick equal distance from the ends. They must also be aligned in the channels in the floor of the seat back. If necessary, bushings can be shortened slightly to fit in the ends of the cross tube. Use a caliper with a depth gauge to determine if you will need to shorten the bushings. This is the pilot's throttle handle, end plug, throttle shaft, and roll pin. Referring to the construction print, assemble the pieces and drill the 1/8 inch hole and install the roll pin. Drill and install the two 1/8 by 1 1/8 steel pop rivets. Do not cut off the excess rubber from the grip. This helps put some friction in the system so that the pilot may at times remove his hand from the collective without the throttle rolling off. Note, an easy way to install or remove the rubber grip is to use an air nozzle to blow air into the small hole in the end of the grip. Install the nylon throttle shaft bushings in the pilot's collective stick as shown. Install the throttle shaft into the stick. Make sure to install a 3/8 inch washer at both ends of the shaft as shown. Drill the 1/4 inch hole in the 3B control arms. The hole should be 1 7/16 to 1 1/2 inches on center of the 3/8 inch hole as shown. Install the B control arm on the throttle shaft and locate and drill the 3/16 inch hole to attach the control arm to the shaft. Cut the shaft to extend 3/4 inches past the control arm as shown. Install the bolt as shown so that the head of the bolt is toward the throttle stop. Place the two B control arms on the transfer shaft. Referring to the construction print, the two B control arms should be 90 to 95 degrees apart. The shaft should extend 3/4 inches past the control arms as shown. Drill the 3/16 inch holes that attach the control arms to the shaft and install the bolts. Install the nylon throttle shaft bushings into the cross shaft weldment. Install the transfer shaft along with 3/8 inch washers into the bushings. Locate per the construction print and drill the 1/8 inch holes for the split pins. Install as shown. To install the passenger's collective control stick, refer to the construction print. The passenger's throttle grip sleeve weldment needs a small notch to be filed out. File an opening 3/8 inch by 1/8 inch as per the print, so that when the bolt is tightened to hold the sleeve to the control stick hub, it will clamp and hold fast. Drill the 1/4 inch bolt hole in the tabs 1 1/2 inches from the end of the tab and 5/16 from this end as shown. Install the bolt, but do not tighten. Install the nylon shaft bushings as shown. Use a socket and an extension to install the bushings in the recessed tubing end. Do not drive the bushing in too hard, or the bushing shoulder could break off. Drill a 1/8 hole 3/8 of an inch from the end of the passenger's throttle shaft weldment sleeve as shown. With a bandsaw, cut the end to the 1/8 inch hole to create a slot in the throttle shaft sleeve as shown. Install a 3/8 inch washer on the shaft and install the shaft into the passenger stick weldment with 3/8 inch washer on the other end. Fit the throttle grip sleeve and end plug over the shaft and mark the throttle shaft to be cut flush with the end plug. Drill the 1/8 inch hole and install the roll pin as shown. Drill the 1/8 inch holes and install the 1/8 inch steel rivets. Install the rubber throttle grip. Mate the passenger stick weldment with a control stick stub and make sure the notch sleeve of the stick weldment engages correctly with both roll pins on the control stick stub as demonstrated here. Then tighten the bolt as shown. With the seat back removed, install the collective assembly in the airframe. Note on final assembly, grease the bushings and mating parts, lock tight the bolts, safety wire the bolts, and rivet the aluminum bushings to the brackets. This is the throttle connector shaft weldment. Tap this end with a 1/4 by 28 threads per inch tap, 3/4 of an inch deep. The other end has been tapped before assembly of the weldment by RotorWay. Install the 1/4 inch male rod ends with a jam nut on each end. Install the throttle connector shaft on the B control arms as shown. It may be necessary to add washers to prevent the transfer shafts from striking the B control arms. As in all manually controlled helicopters, power is added by rolling the throttle outward and closed by rolling the throttle inward. Adjust the rod ends and throttle stops to achieve a minimum of 143 degrees throttle roll at full down collective. This shows the fully open throttle stops. They both should make contact at the same time. This shows the fully closed throttle stops. They both should make contact at the same time. To install the seat back to the airframe, remove the passenger collective and disassemble the B control arm to remove the pilot's throttle shaft assembly. Now raise the collective and place the seat back into position with the collective tubes passing through the holes in the seat back. Bolt the seat back into position and reassemble the pilot and passenger's collective sticks. The total collective stick travel should be approximately 48 degrees. The full down collective stick position should be 2 to 3 degrees negative. This is the full collective up stop. Open the seat back holes as necessary for full collective travel. You will install the throttle cable when the engine is installed. Locate the following components. Reference construction prints E16-2000 directional control. Note, the pedal cross shaft was fitted in Section 8 body installation. With template E16-1 and E16-2, cut out and drill the holes for the scissor beams. Assemble the 2 nylon scissor beam pivot bushings and the aluminum bushing to the scissor beam as shown for both pilot and passenger. Note, the aluminum bushing must extend approximately 10 thousandths through both nylon bushings so that the beam will pivot on the aluminum bushing and not the bolt. As per the construction print, drill the 1/4 inch bolt hole in each of the 4 pedal castings as shown. Fit the pedal weldments and pedal castings and drill the 3/16 inch hole that holds the pedal weldment to the casting. As per the construction print, it shows this hole should be located 3/8 of an inch from the center of the casting as shown. The pedal weldment hole is typically located approximately 1 inch from the end as shown. Install the 1/4 inch male and female rod ends and jam nut to the scissor beam as shown. Apply grease to the mating parts in the scissor beams before installing an airframe bracket. Install both scissor beams to the airframe with the 1/4 inch bolts. Check that the beams are pivoting freely. Install a cross shaft tube with the pedal castings. Connect the scissor beams to the pedal casting using the rods and install the bolts as shown. Install the stop bolts and their jam nuts in the airframe brackets. Install the directional control cable in the bracket. You will have to remove the dust cap to push the cable through the hole in the bracket. Attach the rod end to the cable and bolt it to the scissor beam as shown. Move the scissor beam to the end of travel. Set the stop bolt. Now move the scissor beam to the other end of travel and set the stop bolt. When the scissor beam moves from one stop to the other, the cable should travel a total of 2 7/8 inches. Also check that when the scissor beam is at the center of travel, it should be parallel with the front cross tube of the airframe. Position the pedal castings on the shaft for best alignment of the rod ends between the castings and the scissor beams. The distance between the pedal castings should be about 2 3/8 inches. There must be a minimum of 1/4 inch clearance between the washers on the pedal weldments. Fit the floor pan around the pedal castings for the proper positioning. Remove the pedal weldments. The right pedal is the one that will be bolted to the shaft. Do not drill this hole or place the spacer between the two pedal castings until after the holes in the floor pan are cut out as shown. When the floor pan is in place over the pedals, they may need to be slid from side to side for better positioning. Once the proper position has been found, drill a 3/16 hole through the pedal and shaft and install the bolt. The spacers can now be fitted on the cross shaft. On final assembly, apply Loctite to the threads of the end bolts and tighten. Safety wire the bolts and pop rivet the aluminum bushings to the airframe brackets. This section will instruct the builder to install the secondary unit, drive belts, fan drive pulley, fan, secondary sprocket, the main sprocket, drive chain, and main shaft safety spacer. Locate the following components. Reference construction prints. The main shaft must be installed 90 degrees to the drive mount tubes in the fore and aft and lateral planes. Refer to the main shaft installation procedures in Section 8. Important notice. Before beginning any work on the drivetrain, read and view the video sections 11 through 16 to become familiar with the entire procedure. Follow this sequence when assembling the drivetrain components. 1. Install the main rotor shaft. Do not Loctite the bearings or set the lock rings at this time, because the main shaft will be removed to fit other components. 2. Align the secondary drive unit with the main shaft, shim as necessary, and final install. 3. Install engine and shim as required. 4. Install clutch idler pulley assembly and torque link. 5. Install fan drive countershaft, water pump, alternator, and voltage regulator. 6. Remove chain and raise main shaft to fit oil bath. 7. Final install the oil bath on airframe. Install the oil sealer on the secondary shaft and glue in place. 8. Final install main shaft and drivetrain. 9. Check chain tension, master link, and master clip. Safety wire secondary retainer plate bolts, hub to sprocket bolts, and hub to shaft bolts. 10. Complete oil bath cover and seal it to the oil bath lower pan. Check to verify that a temperature strip is installed on the upper bearing housing of the secondary unit as shown. If this strip is not present, contact the RotorWay Parts Department. The temperature strip is a means of monitoring bearing temperature and should be examined after every flight. The heat-sensitive dots will darken if the indicated temperature is exceeded. During normal operation, the bearing temperature should be in the 170 to 180 degree range and may be slightly higher just after adding grease. If the 200 degrees dot darkens, it is an indication that there is a problem which is causing the bearing to run hot. If this happens, discontinue flight and contact customer service for further assistance. Warning: do not tamper with the 4/4 inch bolts or nuts, as this will cause severe damage to the unit. These are the parts as received from RotorWay. Reference construction print E23-2000 and template E23-1 when constructing the secondary drive. Remove the tail rotor drive pulley and the steel secondary sprocket from the secondary shaft assembly. Note, at this time the main drive belts, upper fan drive belt, and the water pump belt must be installed. Locate the main drive belts. Refer to the instruction attached to the belts on how to separate the one wide belt into 4 narrow belts as shown, each with 1 groove and 2 peaks. Make a starting cut into one of the grooves and go all the way through. Use a razor knife with a new, sharp blade. Remove the knife and insert it into the starting cut from the opposite side of the belt. This will allow you to see the blade and keep it centered in the groove. Have someone help you pull the belts apart as you cut. If needed, lightly touch the edges of the belt on a grinder or sander to remove excess lip. Be careful not to grind the surface of the belt that comes in contact with the pulley. After trimming all the belts, clean them with a rag that is slightly damp, but not soaking, with acetone to remove dirt or any residue. Install the secondary assembly with the belts with the lower secondary shaft centered on the airframe. Place a level on a square drive tube and level the airframe laterally by shimming under the skids if necessary. Level a secondary pulley by pivoting on the locating bolt as shown. When level laterally, tighten the bolts. Use several washers at this time to prevent the nuts from bottoming out until the shims are fabricated to maintain the parallelism to the main shaft and add the proper tension to the drive chain. Place a level on the fore and aft square drive tube and shim under the skids to level the airframe. Place the level on the secondary pulley as shown. Level the secondary pulley fore and aft by placing shims between the airframe and either the upper bearing housing or lower bearing flange. This shows the location of the shims for the upper bearing housing. Fabricate the shims from the material located on E23 card 1F and refer to the construction print for the dimensions. This shows the location for the shims in the lower flange assembly. When tightening the bolts that attach the upper bearing housing to the airframe, check to see if the lower flange tends to push towards or away from the airframe tube. If it does, file the upper bearing housing where it contacts the airframe. It must be filed at an angle so that the lower flange will contact the airframe without being forced in or out. Note, when secondary pulley is level fore and aft and properly shimmed, and the top two bolts in the upper bearing housing are tight, the lower flange and shims should have a snug fit between them and the airframe square tube. Refer to print E23-2000 for the up and down positioning of the bearing assembly. It shows the secondary pulley must have a minimum of 125 thousandths clearance from the top of the square drive tube, and the tail rotor drive pulley must have a minimum of 90 thousandths of an inch clearance from the bottom of the airframe square tube. Place the fan pulley assembly on the fan and mark the outside diameter of the pulley with a felt marker. Note, the fan will be mounted smooth side up. Be sure it is positioned correctly before drilling the holes. Lay out the bolt holes to be drilled for mounting the fan to the pulley. Place the fan drive pulley and the fan on a drill press and drill the 5/16 inch hole. Install that bolt before drilling the next hole. Repeat this procedure until all the holes are drilled and all bolts are installed. Note the fan is temporarily installed so that the radiator and radiator shroud can be fitted in section 18. Do not final install the fan and tail rotor drive pulley until after the radiator and shroud installation is completed. On final assembly, the fan pulley and lower shaft bushing must be Loctited to the secondary shaft. Install the secondary sprocket with the key located on E23 card 1F. Before installing the key, radius the edges of the key where it contacts the shaft, as shown here. The edges should have a 1/16 inch radius. This can be done using a file, grinder, or sander. Do not hammer the key into place. Polish the key with sandpaper until it fits snug. A very light tap is okay. Cut out and drill the holes in a retainer plate using template E23-1. Place the large drive sprocket on the sprocket hub so that the bottom hole in the hub is centered between the spokes without a hole, as shown. Please note, proper drilling of the holes for the bolts that hold the sprocket to the hub is extremely important. Use the letter D drill to drill the 4 holes in the sprocket and hub. Test drill in a piece of scrap material and put the 1/4 inch bolt in the hole to ensure a tight fit before drilling the helicopter parts. Use the drill press, ensuring that the holes are drilled perpendicular 90 degrees to the face of the sprocket. The bolts should fit snug enough that it will be necessary to lightly tap them in place with a plastic hammer. A letter D drill can be ordered from RotorWay Parts Department. On the bottom of the sprocket hub is an index mark. The index mark on the sprocket hub matches one on the bottom of the main shaft. Transfer the index mark to the top. This will ensure correct alignment. Install the large chain sprocket to the sprocket hub and safety wire before installing on main shaft. Install each of the 4 sprocket bolts from the bottom with the head flush to the hub flange. Do not use a washer on the bolt head. Use a combination of 1 or more washers on the nut end of the bolt to locate the nut properly. Note, the nut after final torque must be located on the bolt so that the safety wire can pass through the hole in the shank, yet the nut must not bottom out on the threads of the bolt. On final install, torque the 4 bolts to 7 foot-pounds, then safety wire the bolts as shown on the print. It will be necessary to drill small holes through the sprocket, no larger than 1/16 of an inch in diameter, so that each bolt head may be individually safety wired to the sprocket. The shanks of the 4 bolts should be then wired together. Raise the main shaft to install the sprocket and hub. It is important that the main sprocket has proper clearance, 7/16 inch to 1/2 inch above the square drive tube to ensure correct alignment of the drive chain. Use the 1 3/4 inch washers located on E49 card 2F to obtain the proper alignment. Install 1 or 2 washers to the bottom of the main shaft. Install the 3 bolts that hold the hub to the main shaft and torque them to 18 foot-pounds. Align the top of the secondary sprocket with the top of the main drive sprocket and check the alignment with the straight edge. The straight edge should make contact with the sprocket at the 3 points indicated by the arrows. If necessary, install a fender washer between the top of the shaft and the retainer plate. On final assembly, torque the 3 5/16 inch bolts to 12 foot-pounds. This will be done after the oil bath has been installed. On final assembly, Loctite the lower main shaft bearing to the shaft, set the lock ring, and tighten the set screw. Note, this procedure is to be done after the lower oil bath has been installed. In this application, the bearing lock ring must be set in the direction of rotation. The main shaft turns clockwise viewed from above. This is done by using a drift punch sized for the hole in the lock ring and a hammer approximately 10 to 14 ounces in weight. Strike the punch in the direction the bearing is turning. No more than 2 or 3 strikes are necessary to set the ring into position. Then tighten the set screw firmly. If the application requires Loctite, wait until the Loctite is dry before setting the lock ring. Keep in mind the larger the bearing and lock ring, the more force it will take to set. At this time, you will temporarily install the drive chain. Do not forget the 2 link plates that go between each of the rollers when installing the master link. Do not over-tighten the chain. If you find you cannot draw the ends of the chain together by pulling with your hands, you may have too many shims between the secondary and the airframe. You will discover the proper chain tension will allow you to install the master link by drawing the ends together with only hand pressure as shown. The master link clip should be placed so that the split end is in the trailing position as shown by the arrow. Note, the chain will be removed later for the oil bath to be fitted. Do not install the clip until final assembly. The master link is a pre-flight check item, which is the reason for the plexiglass inspection window in the oil bath cover. Use a straight edge and a spring scale to check the tension of the chain. Pull 10 pounds with a spring scale midway between the sprockets. The chain should move 1/2 inch. To tighten the chain to the proper tension, install shims equally between the top and bottom bearings and square drive tubes on the secondary unit. With the chain at its proper tension, finally install the secondary assembly. Make certain you have the main drive belts, the upper fan drive belt, and the water pump alternator belt installed. Make sure the secondary pulley is level fore and aft and laterally, respective to the square drive tubes, and has the proper vertical position in relation to the pulleys and square drive tubes. Use 5/16 inch large fender washers on the bolt head end. Make certain the lower bearing is Loctited to the shaft and no pressure is being applied to the secondary shaft when tightening the bolts in the lower flange to the square tube. Set the lock ring and tighten the set screw. Place the safety spacer next to the main shaft and mark where it will be cut for a snug fit. Note, make sure the concentric part of the lock ring on the main shaft bearing is seated against the bearing before the aluminum safety spacer is measured for a snug fit. After cutting the safety spacer, check it for a fit. It must fit snug between the lock ring and the sprocket hub. To make a straight line along the length of a tube, lay it on a flat surface. Lay a marker on the surface and slide it from one end of the tube to the other. Clamp a board on the bandsaw table so that when the tube is against the board, the saw blade is centered on the tube. Turn on the saw and slide the tube along the board. The saw blade should stay on the line, cutting the tube into 2 equal halves. Deburr the edges of the safety spacer and install it on the shaft with the hose clamps. Upon final assembly, apply a coating of grease to the main shaft to prevent surface rust. Make sure the safety spacer does not turn on the shaft when the hose clamps are tight. This section will instruct the builder to install the 162F fuel-injected engine, the torque link, the clutch, and the idler pulley. Locate the following components. Reference construction prints. This is the RI 162F engine as received from RotorWay. Before beginning any work with the engine, make sure the exhaust port holes have been taped over with duct tape. If this is not done and a washer or another object might accidentally drop into the exhaust port, you would run the risk of damaging a valve or the engine the first time it is started. The tail boom support brace tubes can be removed for easier access to the engine mount area. However, if this is done, be sure to remove or support the tail boom before removing the support tubes, or damage to the airframe will result. Place the upper engine mount cup into the engine drive pulley mounted on top of the engine. Rotate the bell in the pulley so that the half moon is toward the front of the engine as shown. Fit the rubber strip so it covers the machined area on the inside of the cup. Glue the rubber to the cup with the 3M structural adhesive and rivet in place, using the 1/8 inch washers on both pop rivets. Press down hard to recess the washers into the rubber. The cup is shown here bolted to the upper engine clevis for a better understanding of how they fit together. Note, in Section 8, when the upper engine clevis was installed, an 1/8 inch gap was maintained between the rear of the upper engine clevis and the bottom of the square drive tube. On the engine pulley, note that the distance from the top of the uppermost groove to the top surface is 200 thousandths greater than that of the secondary pulley. It is important to note that if the engine was adjusted and installed with the top of the engine pulley at the same height as the secondary pulley, the main drive belts would be 2/100ths of an inch lower at the engine pulley. To maintain correct engine height, for proper belt alignment, place a piece of marking tape on the engine pulley as shown and mark a reference line 2/100ths of an inch below the top edge of the pulley. Set the engine mount cup into position. Install the engine mount support ring on the bottom of the engine. Set up a jack with blocks of wood in a fashion that will allow you to raise the engine to about 30 inches. The top block should be narrow enough to allow you to install the bolts. Cut a hole deep enough to allow for the oil drain plug. Raise the engine until the upper engine mount cup fits into the clevis. Install the 3 5/16 of an inch bolts that hold the engine mount support ring to the engine mount weldment. If the tail boom supports were removed, reinstall and torque the bolts before checking any alignment or height of pulleys.